Hello everyone, and welcome back to the Geospatial Intelligence PH channel. If you find this content helpful for your mapping and analysis, please make sure to share, like, and subscribe. In this video, I'll show you how to download data from the USGS and import it directly into ArcGIS Pro. In our last video, we covered how to create your USGS account, and now we're ready for part 2. So, without further ado, let's get started. First, open your web browser and head over to USGS. If you don't have an account yet, don't worry, I've linked my previous tutorial in the description below so you can catch up. If you already have one, go ahead and log in now. Remember, you can browse the map freely, but you won't be able to actually download any data for your project without being registered and signed in. Now let's dive in the interface of the USGS. The Search Criteria tab is where you define the geographic area for your project. You can think of this as setting your search area. You have a few ways to do this. You can type in a specific address, upload a KML or shapefile if you already have one, or simply use the map interface. By zooming in on the base map and clicking to drop points, you create a polygon that tells the system exactly where you want to collect your data. Once your area is set, you move to the Datasets tab, which is where you choose the specific type of information you need. One quick tip. You can also change the base map style to fit your preference. Whether you prefer the standard street view, a satellite look, or a simple terrain map, you can switch it up based on what helps you identify your study area best. Just look for the layer icon on the top right of the map interface to toggle between these views. If you have a specific site in mind, you can also create your own points by clicking directly on the base map. As you click, the system will connect those points to form a polygon. This is perfect for when you want to trace a specific mountain range, a watershed, or a city boundary to ensure you only get the data you truly need for your analysis. If you make a mistake or want to start over, you can easily clear your points by clicking the Clear Coordinates button. As you can see, my preferred area was cleared immediately after I clicked it. Now, if you already have a specific boundary defined, let's upload our own shapefile or KML. One very important note. The USGS system has a limit for custom boundaries. Your shapefile or KML cannot exceed 500 points or vertices. If your area is too complex and has more than 500 corner points, the system will not be able to read it and the upload will fail. Make sure to simplify your polygon or use a more basic boundary to stay under that 500 vertex limit so you can proceed with your data selection. If you're still a bit confused about the 500 vertex limit, let me jump over to ArcGIS Pro to show you an example. As you can see here, if I use a highly detailed boundary with hundreds of tiny jagged edges, it creates too many vertices. If yours looks like this, the USGS system will reject it. So, always keep your upload boundaries simple. As you can see here in ArcGIS Pro, every time I add a point to my polygon, the system counts it as a vertex. If you have a single shapefile with a very jagged or detailed border, those points add up fast. If that count goes above 500, USGS Earth Explorer will reject the file. So, if you're drawing a complex area, try to keep your shape as simple as possible, while still covering your study site. To fix this vertex error, the simplest thing you need to do is redraw your shape. When you redraw, focus on the general outline of your study area rather than every tiny detail. By limiting the number of corners and keeping the shape simple, you stay well under that 500 vertex limit. This allows the USGS system to accept your file, so you can finally move on to selecting your data. Now, it's time to archive our shapefile for upload. You must include all the essential components: the .shp, .shx, .dbf, and the .prj, which contains your coordinate system. Important note, you must use the .zip format. Do not use .rar or other archive types because the USGS system cannot read them. Simply select your files, right-click, and compress the zip file to ensure a successful upload. Now, head back to the Search Criteria tab in Earth Explorer and click on KML Shapefile Upload. From the drop-down, make sure to select Shapefile as our data type. Next, just locate that zipped folder we just created and hit Upload. Once the system finishes processing, you'll see a confirmation message saying it was successful. You can then close the pop-up tab, and you'll see your study area perfectly outlined on the base. Once the upload is complete, take a look at the left corner of the interface. You will see all your coordinates plotted and listed right there. This is the system's way of confirming the exact boundaries of your shape. Simultaneously, your base map will automatically zoom in and highlight your area, showing you exactly where your data will be pulled from. Now, let's click on the Datasets tab. This is where we choose the specific type of information we want to download. For our project, we need land elevation data. So we're going to look for digital elevation. Expand that category, and you'll find SRTM. I recommend using the SRTM one, Usgs Glowolits. The most detailed, make sure to select it, as this will give us the DEM in a TIFF file format, which is exactly what we need for the next steps in our analysis. When you click the footprint icon, the little foot shape, you'll see a large red box appear on the map. You might notice that this box is much bigger than the specific area we filtered with our shape. Here's the explanation. USGS data is stored in a grid system of predefined chiles, usually 1 degree by 1. The server doesn't cut the data to your shapefile during the download phase. Instead, it provides the entire tile or tiles that intersect or cover your area of interest. Think of it like buying a whole tile from a hardware store. Even if you only need a small piece, you get the whole square. And later in ArcGIS Pro, we will clip it to our exact shape. Alright, final step here on the website. Click on the Download Options button, the icon with the green arrow. A window will pop up with several choices. You want to look for the one labeled Geo. This is crucial because the GeoTFF isn't just a picture, it has all the elevation data embedded in it. Select the GeoTFF download, save it to your project folder, and we are officially done with the USGS site. Now we are selecting Landsat 8 to 9 collection to level 2 because this specific data provides us with surface reflectance data that has already been professionally corrected for atmospheric haze and noise by the USGS. This is a huge advantage because it means the imagery is analysis ready the moment you download it, saving you the complicated step of manually correcting the pixels in ArcGIS Pro. By choosing Collection 2, you are also ensuring you get the most accurate geometric alignment available, which means your satellite images will perfectly match the coordinates of the shapefiles we uploaded earlier. Since this collection includes both optical and thermal data, it gives you the power to analyze everything from healthy vegetation to ground heat levels within your study area.
Now that we have our results, we need to carefully filter them to find an image with the lowest cloud density possible. Even if an image matches our date and area, thick cloud cover can hide the ground and make your analysis impossible. So we are looking for a clear shot where the land is fully visible. Once you find a scene with minimal clouds, ideally less than 10%. Once you have located a clear image with low cloud density, click the Download Options button, just like we did for the DEM. You will see several individual files. But there is also a product bundle option at the top that contains every single spectral band for that date. Be careful, though the bundle is a heavy file type that can be several gigabytes in size. So if you have a slow internet connection or limited storage, you might want to select only the specific bands. Now that your downloads are finished, you'll see your files sitting in your download folder as compressed archives. Before ArcGIS Pro can use them, you must extract the files. Simply right-click the folder and select Extract All. Once you do this, you'll see all the individual TIFF files, one for each spectral band of the Landsat image and your high-resolution DEM. Make sure to keep these in a dedicated project folder so they are easy to find when we start our technical analysis. Now that we've extracted our data, let's bring it into ArcGIS Pro. I'm going to select and drag bands 1 through 10 into the map view. You'll notice that each band appears as a separate grayscale layer in your contents pane, even though they look like simple black and white images right now. Remember that each one represents a different part of the light spectrum, from the coastal aerosol in band 1 to the thermal data in band 10. By adding all of them, now that we have all our individual bands, we need to use a tool called composite bands. Think of this like a sandwich. Each spectral band is a single layer, and we are pressing them together into one multi-layered file. We do this because it allows us to easily switch between different views, like natural color to see trees and roads, or false color to highlight water and healthy vegetation. Instead of looking at 10 separate grayscale images, now that we have our composite image ready, we can start exploring different band combinations. By changing which bands are assigned to the red, green, and blue channels, we can reveal hidden details like moisture levels, urban heat, or forest health that aren't visible to the naked eye. In the next video, I'm going to show you how to use these combinations to perform a supervised classification. Now that we are in the analysis phase, we can bring back our original high-detail file. We used a simplified version to satisfy the USGS upload limits. But for our actual map, we want the exact precision of our original boundary. We are going to use the clip raster tool. By using our original polygon as the output extent and checking the box to use input features for clipping geometry, we can trim our heavy Landsat composite and our DEM to the exact shape of our study area. This removes all that extra data from the USGS grid and leaves us with a clean, professional-looking project. Now, let's bring in our DEM file using the same method we used for the spectral bands. Just locate your extracted GeoTIF elevation file and drag it into the map. Even though it looks like a simple black and white gradient right now, this layer is the foundation for our entire 7-step mapping process. To keep things clean, we are going to apply the clip raster tool to the DEM as well. Using our original height, now you have all the data we need for this project ready to go in ArcGIS Pro. We've successfully downloaded our DEM and Landsat imagery, clipped them to our original high-precision shapefile, and created a multispectral composite. I hope you've followed along with each step, because having your workspace organized like this is the key to a professional map. You now have the raw ingredients for our entire workflow. I hope this video helps you successfully set up your account and get the USGS data you need for your own projects. If you found this tutorial helpful, please don't forget to follow, like, and subscribe to the channel. Your support really inspires me to keep creating these step-by-step guides for all of you. Every like and subscription makes a huge difference, so thank you for helping me grow this community.